This is Dr. Holt. This is question number 2 on the free response that I assigned. Kind of drew a picture down here, and I'll come back to this. This is the one where I have two masses, have mass M, a large mass here. Now this pulley has no mass, so T1 here and here will be the same, and it shows you that it's going to be accelerating upward in this direction here. I'll come back to the first question they asked you. Question number A says, show that the rolling without slipping means that the speed of the cylinder's center mass, called v sub cm, which is the center mass velocity, is equal to the radius times omega, angular velocity. Okay, what I did here is I have the large mass. This is, I'll call this M. This is big M here, mass, and this is big M here. I showed it as 2 time intervals. This is t is equal to 0, and this is t is equal to t1. So this mass is going to roll as it moves from A to B. So I said delta t is going to be nothing more than t1 minus t0. Now I let this distance be L. Again, if you start thinking angular momentum, L just means some distance. You can change that to any variable you want. So if this mass moves or rolls from A to B, then I put a point here representing A. As this object starts to roll, A is going to start traveling around this point here because it's moving around, right? So as I get to B, A would be up to this point here. Now the radians that's been generated would be nothing more than some value here as I move from this point to this point here. So obviously my velocity of center mass, we'll call this Cm, my velocity of center mass times some delta t will give me the d. So just velocity times time gives me distance. So from here to here. However, we know if we take the radius and we multiply it by the number of radians, we will get this arc length right here. So what I did is I took L out here and I replaced it with R omega. I'm sorry, R theta. Being that's the arc length I traveled. So velocity times delta t is equal to arc length. Now we also know that if I take the angular velocity and multiply it by the radius, I'll get velocity, and then multiply it by delta t, I basically get the same thing. So can I not say that R times my angle that I rotate about is equal to omega times delta t? Because omega, again, is radians per second, times that gives me radians. This right here is theta is represented as just as, let me come back. Let me take off. Let me erase this right here because I don't want to confuse you. All right, let me go back and state it what I said. This part right here, theta, is the same thing as omega times delta t. This is radians per second times t gives me how many radians I traveled. So I replace that, this right here, with R times omega times delta t, as I did here. So I saw that my velocity delta t is equal to omega delta t times R. I canceled out my delta t's here and here. And I'll do that right here and here. And all that's going to give me is V is equal to omega times R, which we knew in the first place, but this is the proof behind it. Okay, part B says show that the relative to point P, that the point of contact of the cylinder with the ramp, the speed of the top of the cylinder is 2 times the velocity center mass. Now this one I went over in class one time, stating that as a wheel rolls you see more blurring up here than you do here because the velocity at this point is going to be greater than the velocity at this point or this point. So if I pick this as my rotation point as a wheel is turning around here, then I could say velocity Cm is going to be nothing more than omega times the radius. If I want to find this velocity here, it would be omega times diameter, or 2r. So I just said velocity of B would be 2 times r omega, and velocity would equal to, and since velocity center mass is r omega, I substitute that back in, and I get velocity of B is 2 times the velocity of center mass, which makes sense because if this is radius and this is 2 radius, obviously the velocity here will be 1/2 that velocity. Excuse me. So these parts weren't too bad. C also is not bad either if you think about it. Works the same way as what we're doing here, and I can actually kind of talk through it in this way. If this object is accelerating down the slope, then I'm also have angular acceleration around the midpoint, or we can say around this point. So the angular acceleration here would be 1/2 the angular acceleration. Excuse me, let me repeat that. The linear acceleration, which would be alpha times radius here, would be 1/2 the alpha times 2 radius here. So obviously here I might get greater acceleration than I would here. So it's stated here, the acceleration at some point up here, just saw this little point here, would be alpha times 2r, and the point here would be alpha center mass, excuse me, acceleration center mass would be alpha times r. So we can tell from that, we go back to the picture, that this object here is going to accelerate upward twice what the object here is going to accelerate downward. Because again, if I draw a vector representing the acceleration of this object down the slope, then it's the same thing as alpha times this radius here. This string here, or what's attached to mass m, is going to be accelerating alpha times 2r. So I can say mass here is going to be 2 times the mass of this center mass. And that's how you would set up part C. All right, now let's get into the harder parts. Really, D and E are really, really tough. I don't think you'd quite see one quite this difficult on the AP exam. What I would recommend, though, is that you work it very similar to what I did. Even if you don't get the right answer, they're probably only going to give you about 1 point for having the correct answer. However, showing the work and showing step by step by step is probably going to get you about 3 to 4 points for the AP. So even if you don't know exactly how to do the problem, do your very best, show as much work as possible, because the people who are evaluating this are trying to reward you with as many points as they can. They just got to see the work to do that. All right, so what I did to start part D, I do free body diagram of this mass here. So here I'd have mg, I'd have my T1 going up. It's going to accelerate upwards, so it'll be mass times am, meaning this is acceleration of m. So I solved for T1, and I got T1 is equal to m times acceleration of m plus mg. Then I went back and drew a free body diagram of this object here. Now, if this object is rotating, it must have some type of frictional force here. Even though the problem doesn't state it, it has to have some type of frictional force. So the forces that would be pulling on the center of mass of this object would be friction, T1, which is the tension in that cable. I have this one here, which is going to be mg coming down, times the sine of this angle is going to give me this vector coming down this way. This one, which I don't really have to worry about, would be mg cosine theta, and then F normal would equal to mg cosine theta. So I said the summation of forces in the x direction, meaning this is the x direction, would be minus t plus minus my friction plus mg sine theta must equal to m times the acceleration of the center of mass of this big M. All right, then you have to consider, you also have torque here. So I would have the T1, I wrote that as mass times AM, mass times the acceleration of mass M plus mg. Again, that's all coming back from what I established here as T1. That would be my tension. And then I have my frictional force here. So I went ahead and said torque, summation of torque is I times alpha. I let anything that goes back this way be positive. So I'd have my little m times acceleration of m plus mg times r minus friction times r is equal to the moment inertia, which is going to be 1/2 mr squared. And again, I'm making that negative because it's going this way, accelerating this way, alpha is. And I set that again, set that equal to alpha, but we know alpha is equal to ACM over r. So notice here, you can cancel out all the r's go away, as stated here, because you cancel this out, you cancel this out, that gives you an r, and r on each side, those all cancel out. So now you get down to an equation here. All right, what I did now is I took, which equation? I took this equation right here and brought it back down and dropped it in here. Now I took the torque out, not the torque, sorry, I took the T out, which is the tension in the cable, and replaced it with what we said it was right here. Substituted it back in. I have a brand new equation from doing that. As you can state here, and just go through this carefully. Now what I'm going to do is I'm going to add it to this one here. So I brought this one right down to here. What I want to try and do here is eliminate the friction. So I multiply everything by negative straight across here. Added everything together, and what I end up getting is negative 2 times little mass times acceleration of this little mass minus 2 times little mass times g plus big mass times g times sine of theta is equal to 3/2 big M times acceleration of the center mass of this big M. All right, now the careful point, the thing is I have a center mass here, acceleration center mass, I have acceleration of mass. I want to find out first what the acceleration center mass is. So what I'm going to do is I took this one out here and replaced it with what we said before, that the acceleration of little m is going to equal to 2 times the acceleration of the center mass of big M. Substituted it back in. Went and did the multiplication, and now all I'm going to do is isolate the acceleration of center mass. So I moved this over to the other side, got this, pull out acceleration of center mass, and then divide by 3/2 m plus 4 ACM. Oops, right there's a mistake. I need to get rid of that. I need to get rid of this right here. Sorry about that. So it'd be 3/2 big M plus 4. And let's do the same thing here. Can't apologize for that. All right, so again, all I'm doing is solving for the acceleration of center mass here, and you're going to get this equation right here. Now we go back and we know the acceleration of little m is twice this one, so just multiply everything by 2, and you're going to get the correct answers. Again, if you could work this problem through here and get down in these areas here and have these good equations, the person that's judging is going to give you the majority of the points. It isn't that essential that you get an answer that's exactly like that. It's the step-by-step approach, or the methodical approach that leading you to the correct answer is going to get you the most of the points. All right. Hope this helped you with the free response.